August 7th, 1944. The Normandy hedgerows, 3 miles south of Mortain. The sound reaches Obergefreiter Klaus Weber before anything else. Not the sharp crack of Mauser rifles. Not the buzzsaw shriek of an MG-42. This is different. A deeper, rhythmic thump, thump, thump that resonates in his chest cavity like a second heartbeat. Each report carries a physical weight that seems to press against his eardrums. Klaus crouches lower behind the stone wall bordering the sunken road, his fingers white-knuckled around his Kar 98K, and tries to identify the source. He can't. The sound is everywhere and nowhere. It echoes off the bocage hedgerows, those ancient earthen walls topped with gnarled trees that turn every field in Normandy into a fortress. His squad, what's left of it, huddles in the narrow lane, 8 men from the original 40 who crossed the Channel coast 6 weeks ago. Gefreiter Manfred Koch, the baker's son from Hamburg, presses against the opposite wall. His lips move in what might be prayer. Then Klaus sees it. 200 metres down the road, where the lane curves past Bouchard's burned farmhouse, the corner of the stone wall simply disintegrates. Not chips, not cracks. The limestone explodes into powder and fragments, a hole the size of a dinner plate appearing in the 200-year-old masonry. Another impact, 3 metres left. Another hole. The wall is being systematically demolished, stone by stone, and whatever is doing it hasn't even found their position yet. Panzerbuchse, Manfred's voice cracks on the word. Anti-tank rifle? Klaus shakes his head. He's seen what the British boy's AT rifle does to stone. This is something else. The holes are too big, too clean, and the rate of fire is impossible for any anti-tank rifle he knows. The third impact hits the wall directly in front of Gefreiter Hans Zimmermann. The stone doesn't just break, it vaporizes. The round punches through 18 inches of limestone and dirt like it isn't there, and Hans Zimmermann ceases to exist from the chest up. The supersonic projectile creates a pink mist where his torso used to be before the body even understands it's dead. What remains topples sideways, and Klaus feels hot droplets spatter across his face. He doesn't scream. None of them do. They've been in combat for 6 weeks. They've seen death. But this is different. This is industrial, impersonal. A machine designed to erase human beings from existence with the casual efficiency of a factory press. Rückzug! Unteroffizier Dietrich screams from somewhere behind them. Retreat. But retreat where? The sunken road runs straight for 50 metres before the next intersection. 50 metres of absolute exposure to whatever nightmare weapon the Americans have zeroed on their position. Klaus risks a glance over the disintegrating wall. 300 metres across the open field. He spots it. An American half-track, the M3 personnel carrier they've learned to recognise. But this one has been modified. Mounted in the rear bed, behind an armoured shield, sits the largest machine gun Klaus has ever seen. The barrel is as thick as his wrist. The muzzle brake channels the blast sideways in twin jets of flame and pressure that flatten the grass in a 3-metre radius, and it's traversing toward them. The gunner is invisible behind the shield, just a helmet and a pair of hands on the spade grips. Klaus watches those hands make a minute adjustment, sees the massive barrel swing 2 degrees right, and knows with absolute certainty that he's looking at his own death. The gun fires again. The sound is apocalyptic. Each round creates a shockwave Klaus can feel in his bones, a subsonic thump that accompanies the supersonic crack of the projectile. The wall erupts in a continuous stream of impacts now, the gunner walking his fire along the length of their position like a gardener watering plants. Limestone, earth, and human beings receive the same treatment, obliteration. Unteroffizier Dietrich makes his decision. Laufen, jetzt, they run. Klaus vaults the disintegrating wall and sprints for the hedgerow 30 metres across the field. His boots slip in the August mud. His lungs burn. The thump, thump, thump continues behind him, a rhythm that sounds almost lazy, almost casual, like the weapon has all the ammunition in the world and all the time to use it. Gefreiter Werner, running 5 meters to Klaus's left, makes it 20 meters before a 50 caliber projectile finds him. Klaus doesn't see the impact. He's focused on the hedgerow, on survival, on the next 10 meters. But he hears the wet, meaty sound of the round transiting Werner's body. Something hot and wet sprays across Klaus's right arm. He doesn't look. He doesn't slow down. 15 meters to the hedgerow. The gun shifts fire. Klaus hears it tracking, hears the impacts walking across the field toward him. Explosive puffs of earth marking each strike. 10 meters. 5 meters. He dives headfirst into the thorny embrace of the bocage, feeling branches tear at his uniform, feeling the blessed earth rise up to meet him. The firing stops. In the sudden silence, Klaus can hear his heart hammering, can hear Manfred sobbing somewhere in the undergrowth, can hear the American half-track's engine idling across the field, a diesel purr that sounds almost peaceful. Klaus pulls himself deeper into the hedgerow, thorns drawing blood from his hands and face. He doesn't care. He's alive. Out of 8 men in the sunken road, he counts 4 voices in the hedgerow, 4 survivors. The American weapon, whatever devil's machine it was, killed half his squad in under 30 seconds. Behind them, the half-track's engine revs. It's moving up, claiming the ground they abandoned. Klaus can hear American voices now, calling to each other in that strange, casual English that sounds almost cheerful. They're not even excited. This is routine for them. Another hedgerow cleared, another German position neutralized, another 50 meters of France reclaimed. Manfred crawls up beside Klaus, his face white except where splattered blood makes a red mask. "What was that?" he whispers. "What the hell was that?" Klaus has no answer. In 6 weeks of combat, he's faced American rifles, American mortars, American artillery, American tanks, and American air power. He's watched friends die in a dozen different ways. But this was something new, something that made their stone walls into paper, their cover into concealment, their defensive positions into coffins. 50 caliber, Unteroffizier Dietrich says, sliding into position beside them. His voice is flat, dead, the tone of a man who's just had a fundamental assumption about warfare destroyed. The Americans call it the 50 caliber. Oberleutnant Werner warned us about it in the briefing. I didn't believe him. 50 caliber, Manfred repeats. That's just a machine gun caliber. We have machine guns. The MG42 is not like that. Dietrich's laugh is bitter. Not even close to that. Klaus wipes blood from his face. Hans Zimmermann's blood, Werner's blood. He doesn't know and doesn't want to know. And listens to the American voices growing louder. They're moving up with infantry now, consolidating the position, preparing for the next push. Somewhere in the distance, more of those devil guns open fire, their distinctive thump, thump, thump echoing across the Norman countryside like the beating of monstrous hearts. In that moment, Klaus Weber understands something that German High Command hasn't yet fully grasped, something that will take another year of retreat and defeat to drive home. The Americans haven't just brought more men and more tanks to this war. They've brought a different philosophy of violence. More fire, more metal, more ammunition than any military in history, all delivered with industrial efficiency and mechanical precision. The 50 caliber machine gun isn't just a weapon. It's a statement. It says, we can afford to throw half-inch projectiles at you all day, every day, until you're dead or you surrender, and we'll never run out. Klaus has fought the British with their careful tactics and measured responses. He's fought the Soviets with their human waves and desperate courage. But the Americans? The Americans fight like a nation that's never known scarcity, never known limits, never known the word conserve. And that 50 caliber gun, still firing somewhere across the fields, is the purest expression of that abundance. The sound of Deuce, though Klaus doesn't know that name yet, doesn't know that American gunners call this monster Deuce, with a mixture of affection and respect, will haunt his dreams for the rest of his life. The ones that do the haunting always do. But first he has to survive the next hour, the next day. The long retreat east through France, through Belgium, back into Germany itself, all the way to the final collapse in 1945. And every step of that retreat, he'll hear it. Thump, thump, thump. The sound of American industry, American abundance and American firepower concentrated into a machine that was never supposed to exist, that couldn't exist, not according to everything Klaus learned about machine gun design and practical warfare. But John Moses Browning never cared much about what was supposed to be possible. September 1918. American Expeditionary Force Headquarters, Chaumont, France. General John Joseph Blackjack Pershing stands at the window of his commandeered chateau, watching smoke rise from the Saint-Mihiel salient 20 miles north. His first major offensive as commander of American forces in Europe is succeeding. But the butcher's bill keeps climbing, and Pershing knows exactly why. The numbers don't lie. Casualty reports cross his desk every morning, typed on flimsy paper that somehow makes the losses feel even more disposable. Killed by artillery, killed by machine gun fire, killed by aircraft. And increasingly, a new category that makes Pershing's jaw clench, killed by armoured vehicles. The Germans have brought innovations to this war that American doctrine never anticipated. Their Fokker D-7 fighters strafe American positions with near impunity, diving low to rake trenches with machine gun fire before climbing away faster than infantry rifles can track. Their A-7V tanks, crude and ungainly as they are, lumber across no man's land with enough armour to shrug off .30 caliber bullets like rain. Their observation balloons hang in the sky, directing artillery with devastating precision, practically begging to be shot down. Except nothing in the American arsenal can reach them reliably. And the American infantry, brave as they are, die trying. Pershing turns from the window and picks up the weapon lying across his desk. A Browning M1917 machine gun, or rather, a scale model of one. The real thing weighs 103 pounds with its tripod and water jacket. A magnificent weapon, perhaps the finest light machine gun in the war. John Moses Browning's design has saved American lives from the moment it entered service. The .30-06 round it fires is accurate, efficient and perfectly adequate for killing infantry at 600 yards. But perfectly adequate isn't good enough anymore. Pershing has seen what happens when his men try to engage German aircraft with the M1917. The .30 caliber rounds lack the mass, the energy, the raw kinetic punch to reliably damage aircraft structures before the pilot breaks contact. He's watched American machine gunners pour fire at A-7V tanks, watched the bullets spark off armour plate, watched the tanks keep coming. The French have solutions. Their 11mm machine guns pack more punch. The British are experimenting with .50 caliber rifles. But Pershing doesn't want foreign weapons with foreign logistics chains and foreign spare parts. He wants an American answer. Better yet, he wants John Browning's answer. On September 15th, 1918, Pershing drafts a cable to Washington. The language is direct, almost blunt, stripped of the usual military politeness. American forces require a machine gun of approximately .50 caliber for anti-aircraft and anti-armour applications. Development is urgent. Who can deliver? The answer comes back within days. If anyone can, it's Browning. John Moses. Browning receives the War Department telegram in his workshop, a converted barn that smells of gun oil, metal shavings, and 60 years of innovation. He's 63 years old, silver-haired, with hands that bear the calluses and burn scars of a lifetime spent transforming ideas into steel. Those hands have already revolutionized American firearms 4 times over. The Winchester lever actions, the Colt 45 automatic pistol, the Auto 5 shotgun, and just last year, the M1917 machine gun that Pershing's forces are using to such great effect. Now Pershing wants him to do it again. Bigger. Browning reads the specifications 3 times. A 50 caliber machine gun, half an inch in diameter, roughly twice the bullet weight of his M1917. Roughly 3 times the kinetic energy, capable of engaging aircraft, armour and fortifications, reliable enough for military service, light enough for mobile deployment. Oh, and the War Department would very much appreciate it if he could have a working prototype ready for testing by the end of the year. It's October. That gives him roughly 10 weeks. Most engineers would blanch at the timeline. Browning simply nods and sets to work. The fundamental problem is one of scale and physics. You can't simply bore out an M1917 to 50 caliber and call it finished. The forces involved increase exponentially, not linearly. A cartridge powerful enough to threaten aircraft and armour will generate chamber pressures that would tear apart a scaled-up 30 caliber design. The bolt, the barrel extension, the locking system, the receiver, everything must be recalculated, reinforced, reimagined. But Browning has an advantage. He's already solved the core problem. His short recoil system, proven in the M1917, is based on principles of physics that don't change with caliber. The barrel and bolt recoil together for a short distance, locked by lugs. The barrel stops. The bolt continues rearward, extracting the spent case and compressing the driving spring. The spring pushes the bolt forward, chambering a new round and locking back into battery. Fire. Repeat. The genius of the system is its simplicity, and simplicity scales. Browning begins with the cartridge. There's no point designing a gun around ammunition that doesn't exist, so he works simultaneously on both. The 50 Browning machine gun cartridge, soon to be known simply as 50 BMG, and the weapon to fire it. The round takes shape over weeks of calculation and testing. A 2.5-ounce projectile propelled by 240 grains of powder, generating 13,000 foot-pounds of muzzle energy. For comparison, his M1917 generates 2,700 foot-pounds. This isn't twice the power, it's 5 times the violence. The first prototype emerges in late November 1918, a water-cooled monster designated the M1921. It weighs 120 pounds with its tripod. The barrel is wrapped in a copper cooling jacket that must be filled with water before extended firing sessions. The receiver is massive, overbuilt, designed to contain forces that would destroy lesser weapons. On November 11, 1918, the armistice is signed. The Great War ends. Most weapons development programs would die right there. No more war, no more urgency, no more funding. But the military brass who witnessed Browning's first demonstrations understand they're seeing something that transcends any single conflict. This isn't just a weapon. It's a new category of firepower. The early tests are almost comical in their one-sidedness. Browning sets up captured German armour plate at 200 yards. The 30 caliber M1917 plinks against it uselessly. The 50 caliber M1921 punches through like the steel isn't there, leaving clean holes with petalled edges where the metal simply surrendered to physics. They test it against aircraft fuselage materials, against engine blocks, against concrete fortifications. The results are consistent. The 50 BMG cartridge, delivered by Browning's reliable action, destroys everything it touches. But the M1921 is too heavy, too cumbersome, too dependent on water cooling. Browning knows it, the Army knows it. So the development continues through the 1920s. Refinement after refinement, iteration after iteration. The water jacket comes off, replaced by a heavy air-cooled barrel with radiating fins. The weight drops. The rate of fire increases. The design becomes more modular, more adaptable. By 1933, 15 years after Pershing's original request, the weapon reaches its final form, the M2 Browning machine gun. It weighs 84 pounds without the tripod. It fires 450, 600 rounds per minute. It can be configured for left or right feed, mounted on aircraft, vehicles or tripods. The universal receiver means the same core weapon serves every role. You just swap furniture and mounts. And most importantly, it works. In the mud of training ranges, in the heat of desert tests, in the cold of winter exercises, the M2 fires and fires and fires, eating belts of ammunition with mechanical indifference, converting 50 BMG cartridges into violence at a rate that makes the old M1 1821 look quaint. John Moses Browning doesn't live to see his creation's finest hour. He dies in 1926, collapsing in his Belgian workshop while working on yet another firearm design. But his .50 caliber machine gun, his answer to Pershing's problem, will serve for the next century and beyond. Because Klaus Weber, huddled in a Norman hedgerow in August 1944, isn't facing a weapon. He's facing John Browning's ghost, delivered at 2,900 feet per second, 450 times per minute, from a machine that was designed to kill aircraft and instead proved it could kill absolutely anything. Pershing wanted a heavier machine gun. Browning gave him Deuce. And the world would never be the same. The Army Ordnance officers watching John Browning's latest prototype have seen promising weapons fail before. They've seen brilliant designs choke on their first belt of ammunition, seen revolutionary mechanisms jam after 50 rounds, seen engineers make excuses about tolerances and environmental conditions, and bad luck. What they're watching now defies every expectation. The M2 prototype has been firing continuously for 8 minutes. The barrel glows a dull red in the winter air, heat shimmer rising from the metal. The weapon has consumed 3,600 rounds of 50 BMG ammunition, each cartridge generating chamber pressures of 55,000 pounds per square inch, each recoil impulse slamming 120 foot-pounds of force through the action. And it hasn't missed a single cycle. The weapon fires, ejects, feeds and fires again with metronomic precision. The spent brass arcs through the air in a glittering stream, tinkling against the growing pile of empty cases. The target, a 1918 German A7V tank hull positioned 800 yards downrange, acquires new holes at the rate of 8 per second. When the test officer finally signals ceasefire, the silence feels almost unnatural. The weapon sits there, barrel radiating heat, action locked open on an empty chamber, completely undamaged, ready to do it again. One of the officers, a major who spent 3 years in France watching lesser weapons fail, asks the question everyone is thinking: how the hell does it work? The answer is physics, engineering genius, and the kind of elegant simplicity that only comes from a lifetime of understanding how metal moves under stress. Imagine trying to catch a bowling ball thrown at your chest. If you lock your arms rigid and try to stop it dead, the impact breaks your wrists. But if you catch it and move backward with it, absorbing the energy over time and distance, you can control forces that would otherwise destroy you. That's short recoil operation, translated into steel. When a 50 BMG cartridge fires inside the M2's chamber, the explosion generates enough force to push a 2.5-ounce bullet to 2,900 feet per second. But Newton's third law doesn't care about bullets. Every action has an equal and opposite reaction. The same force pushing the projectile forward also pushes the breech backward with catastrophic violence. In a locked breech weapon, all that force would try to rip the gun apart. The bolt would attempt to open while chamber pressure was still lethal, potentially detonating the next round in the feed tray or blowing the weapon to pieces. Browning's solution: let the barrel move. Ask any veteran who served with the M2 Browning, and chances are you'll hear the same story. We were told we couldn't shoot enemy personnel with the 50. Geneva Convention said it was illegal, too inhumane. So we aimed for their equipment instead: belt buckles, canteens, helmets, rifles. If the enemy happened to be wearing the equipment at the time, well, that was just bad luck. It's repeated in barracks, told to new gunners, passed down through generations of soldiers like gospel truth. It appears in forums, comment sections, and supposedly authoritative military websites. There's only one problem: it's completely false. The Geneva Conventions, neither the 1929 version in effect during WPE nor the 1949 revision that followed, contain no prohibition on caliber size for anti-personnel use, no restriction on .50 caliber specifically, no clause about machine guns being too powerful for use against human targets. The actual laws of war prohibit weapons that cause superfluous injury or unnecessary suffering. Things like poison gas, exploding bullets designed to fragment inside the body, or weapons that cause injuries impossible to treat. A clean bullet wound, even from a half-inch projectile, doesn't qualify. It's horrific, yes. Inhumane, perhaps. But illegal? No. The Judge Advocate General's Office has issued clarifications multiple times. .50 caliber machine guns are legal anti-personnel weapons under all international laws and conventions. Full stop. So where did the myth come from? The most likely origin is a misunderstood briefing somewhere in the fog of WW2 training. An instructor trying to explain proper target selection for the M2 probably said something like, "The 50 is for hard targets, vehicles, aircraft, fortifications. Use your M19-9 30 cal for personnel. Save the 50 for when you need it." Sound tactical advice. Ammunition conservation, using the right tool for the job, but somewhere in the telephone game of military communication, should use became must use, which became legally required to use, which became the Geneva Convention says you can't shoot people with the 50. And once a myth enters military culture, it becomes unkillable. Cadre tell new soldiers. New soldiers become veterans and tell the next generation. The lie calcifies into tradition. Why does it persist? Partly because it makes a good story. The idea of American gunners finding a loophole, technically following rules while absolutely destroying the enemy. It fits the narrative of American cleverness and legalistic thinking applied to warfare. But there's a darker reason. The myth persists because it makes the truth more palatable. Because what the .50 caliber actually does to human beings is so catastrophic that soldiers instinctively feel like it should be illegal. Gefreiter Ernst Becker, 352nd Infantry Division, learns the truth about .50 caliber fire on June 8, 1944, 2 days after D-Day. His company occupies a stone farm building near Carentan, the kind of structure that sheltered Norman farmers for 300 years. With walls 3 feet thick. It feels safe. It isn't. The first .50 caliber round hits the wall at chest height and penetrates 18 inches before the limestone stops it. Dust explodes from the impact point. The second round hits 6 inches left and punches. All the way through, 3 feet of stone, mortar and history, before exiting the interior wall and embedding itself in the opposite side. Becker and his squad mates realise with crystalline clarity they're hiding inside a structure that provides exactly zero protection against American heavy machine guns. This is the real terror of the M2, not that it kills, every weapon kills, but that it fundamentally changes the infantry equation. Throughout military history, soldiers have understood, get behind something solid and you're safer. Stone walls, buildings, berms, logs, vehicles. Cover reduces your vulnerability. The .50 caliber makes that calculus obsolete. field fortifications that stop rifle fire disintegrate under 350 calors. Walls that provide protection against the MG42 might as well be paper. The sandbag positions German infantry doctrine considers adequate required triple thickness when facing Deuce. Vehicle armour that shrugs off small arms fire develops fatal holes. A German training document from late 1944, recovered near Aachen, includes this guidance. When engaged by American 12.7mm weapons, standard cover is insufficient. Seek terrain defilade, reverse slope, deep ditches, below-grade positions, or withdraw beyond 200 metres. Wall and building positions should be considered compromised. Read that again. Withdraw beyond 3/4 of a mile. That's the respect German tactical doctrine learned to give the M2. But the physical penetration is only half the equation. The other half is pure psychology. Listen to recordings of 50 caliber fire, and you'll hear why it terrorizes. The report isn't sharp like a rifle or the ripping canvas shriek of an MG42. It's a deep bass boom that you feel in your chest cavity as much as hear with your ears. Each round creates a shockwave, a pressure pulse that announces something very large is coming toward you very fast. And unlike the MG42's 1200 RPM blur, the M2's slower 450-600 RPM cadence lets you hear individual shots. You can count them. You can track them. You can hear the gunner walking fire toward your position. Thump, 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 and know with terrible certainty that the next round might be the one with your name on it. Sergeant James Henderson, 2nd Armoured Division, describes the effect. We'd set up the 50 and fire a few bursts, not even aiming at the Germans necessarily, just letting them know we had it. You could watch them change their whole plan. They'd been moving up to attack. Suddenly they're digging in or pulling back. The sound alone was worth a platoon of riflemen. This is battlefield psychology at its purest. The M2 doesn't just kill, it paralyzes enemy decision-making, forces tactical changes, denies terrain without firing a shot. By mid-1944, German forces have developed specific tactics for dealing with 50 caliber positions, outlined in captured tactical manuals. Never attack directly. The effective range and penetration make frontal assaults suicidal. Use artillery. The M2 position becomes an artillery priority target, same as an anti-tank gun or mortar position. Flank with infantry. Small teams with Panzerfausts or grenades, moving through dead ground. Wait for nightfall. The M2's main advantage is range and accuracy. Both diminish in darkness. If you can't counter it, avoid it. Route around confirmed 50 cal positions whenever possible. That last point is telling. German infantry learns to treat Deuce positions the way they treat minefields, as terrain denied, to be avoided rather than contested. An interrogation report from September 1944 captures this evolution. A captured Hauptmann from the 12th SS Panzer Division tells his interrogator, "Your 50 caliber machine gun changes how we fight. Against your 30 caliber, we advance by bounds, use suppressive fire, close the distance. Against the 50 caliber, we call for artillery. It is not an infantry problem. It is a combined arms problem. You have made a squad-level weapon that requires battalion-level assets to counter." That's the real reason Germans hated the M2, not because it was illegal. It wasn't. Not because it was inhumane by the standards of war, questionable, but because it was asymmetric. It gave American squad leaders firepower that forced German companies to completely change their tactical approach. By war's end, US Army operational research studies produce estimates. German forces required an average of 3 times longer to assault positions defended by M2 machine guns versus comparable positions with only 30 caliber weapons. Casualty ratios favoured the defenders by margins of 5.1 or higher in documented engagements. The M2 didn't win the war. No single weapon does. But it gave American forces, often green troops facing veterans, a qualitative edge that helped compensate for experience gaps. And it gave the enemy nightmares. Klaus Weber, interviewed by Allied intelligence after his capture in September 1944, provides the most honest assessment. The sound of your .50 caliber gun is worse than incoming artillery. Artillery is random, impersonal. The .50 is aimed. Someone on that gun is choosing to erase you from existence, and there is nothing, no wall, no cover, no distance short of a kilometre, that can save you. That is true terror. No Geneva Convention needed. The M2 was perfectly legal, which somehow made it even more frightening. For the first 3/4 of an inch of recoil, the barrel and bolt stay locked together as a single unit. The barrel itself, all 45 inches and 25 pounds of it, moves backward in the receiver, guided by smooth, bearing surfaces. During this critical moment, chamber pressure drops from 55,000 psi to safe levels as the bullet exits the muzzle. Then, and only then, does the barrel stop against its buffer. A precisely machined cam surface forces the bolt to rotate, unlocking the lugs. Now the bolt is free to continue rearward alone, extracting the spent case and ejecting it through the port. As it travels back, it compresses a massive driving spring, storing energy like a mechanical muscle. The spring releases. The bolt slams forward, stripping a fresh round from the belt, ramming it into the chamber. As the round fully seats, the bolt rotates back into battery, locking lugs engage barrel extension, and everything is locked up tight again, just in time for the firing pin to drop and start the cycle over. The entire process takes 1/10 of a second, and it works because Browning understood that you don't fight recoil, you choreograph it. The M2's receiver is a rectangular steel box that weighs 24 pounds and contains no complex parts, just precision machined surfaces for the bolt and barrel to travel through. But this apparent simplicity conceals revolutionary adaptability, because the receiver doesn't care what's bolted to it. Mount it on a tripod with spade grips, add a simple trigger mechanism, and you have an infantry heavy machine gun. Bolt it to an aircraft cradle with solenoid triggers and sync gear, and you have an aerial weapon. Attach it to a ship's pedestal mount with extended triggers, and you have naval anti-aircraft armament. Suspend it in a tank turret with mechanical linkages, and you have armour armament. The same receiver, the same bolt, the same barrel, just different furniture. Previous machine gun designs required unique configurations for each application. An aircraft gun was fundamentally different from an infantry gun, but the M2's modular philosophy meant one production line could supply every branch of service. One spare parts chain could support every platform. One training program could qualify gunners for every mission. This wasn't just clever engineering, it was logistics genius that would prove decisive when America needed to arm for global war. Open the M2's top cover and you'll notice something unusual. The feed mechanism works from either side. Most machine guns are stubbornly one-handed. Belt feeds from the left, empty cases eject right, and that's that. Tank designers and aircraft engineers learn to work around these limitations, sometimes mounting guns awkwardly or adding complex belt chutes just to accommodate fixed feed directions. Browning said, "Why?" The M2's feed mechanism uses a sliding block actuated by the bolt's motion. Flip a few parts around, adjust the belt guides, and suddenly your left feed gun becomes a right feed gun. For aircraft designers trying to mount weapons in wing roots or nose positions, this flexibility was revolutionary. For tank designers balancing ammunition storage with crew space, it was a godsend. P-47 Thunderbolt fighters mounted 4 50 cals in each wing, 4 left feed on one side, 4 right feed on the other, all ammunition feeding inboard toward the fuselage where the cans were stored. Try that with a fixed feed weapon, and you'd need complex crossover systems that add weight, complexity, and failure points. The M2 just did it. No fuss, no compromise. The M1921 prototype required water cooling because nobody knew if air alone could handle 0.50 BMG heat generation. The water jacket added weight and complexity. You needed to carry water, monitor levels, prevent freezing in winter and boiling in summer. By 1933, metallurgy and barrel design had advanced enough to eliminate the jacket entirely. The M2's barrel was simply heavier, a thick-walled tube with external fins to maximise surface area. Air cooling through convection and the occasional barrel change for sustained fire. This single change, heavy barrel, no water, made the weapon practical for vehicle mounting. Half-tracks, jeeps, light tanks, patrol boats, platforms that couldn't carry water supplies could now carry Deuce. The tactical applications exploded overnight. The Aberdeen officers watching that January 1933 test didn't just see a machine gun perform. They saw the solution to a decade of doctrinal questions. How do we arm our aircraft against improving enemy fighters? How do we give tanks infantry suppression capability? How do we provide anti-aircraft protection for frontline units? The answer was sitting there on the test mount, barrel still glowing, chamber still slightly smoking. One weapon. Universal application. Absolute reliability. And in 1933, with storm clouds gathering over Europe and Asia, with German rearmament accelerating and Japanese expansion spreading across the Pacific, the timing couldn't have been more perfect. Because America was about to fight a war on every continent, in every climate, against every type of target imaginable. And Deuce was ready. November 8, 1942. Beach red, Fadala, French Morocco. The first German soldier to die by .50 caliber fire in World War II probably never heard the gun that killed him. Operation Torch, America's debut in the European theatre, brings 35,000 troops ashore on North African beaches, and with them hundreds of M2 Browning machine guns mounted on everything that floats, rolls, or flies. The Vichy French defenders, fighting half-heartedly for a government they barely support, discover what concentrated Cena .50 caliber fire does to coastal fortifications. It erases them. Staff Sergeant Mike Kowalski from Pittsburgh mans an M2 mounted on the bow of a Higgins boat, part of the first wave hitting Fadala Harbour. His target is a concrete pillbox 200 yards up the beach, its embrasure winking with Hotchkiss machine gun fire. Kowalski doesn't try for precision. He doesn't need it. He simply holds the trigger and walks his tracers into the target. The first dozen rounds crater the concrete around the embrasure. The next dozen punch through. What happens inside that pillbox doesn't bear description. .50 caliber rounds ricocheting inside a concrete box turn the interior into a blender. The Hotchkiss gun falls silent. Kowalski will later tell Stars and Stripes, "It was like using a sledgehammer on a mailbox. Way more gun than we needed, but damn if it didn't work." That's the American philosophy of firepower in one sentence. By the time German forces counterattack through Kasserine Pass, they've heard rumours about the American heavy machine gun. Prisoners have mentioned it. Intelligence reports have noted it. But knowing something exists and experiencing it are entirely different things. Oberst Ludwig Bauer, commanding a Panzergrenadier battalion in the 21st Panzer Division, watches his half-tracks advance toward American positions and encounters Deuce at scale for the first time. The Americans have positioned M3 half-tracks in hull-down positions along the ridgeline, only their .50 caliber mounts visible above the terrain. Bauer's force outnumbers them. He has 15 vehicles to their 7. He has veteran troops who conquered France and drove to the gates of Moscow. He has momentum, initiative and orders to break through to the supply depot at Thala. What he doesn't have is an answer to sustain .50 caliber fire. The engagement opens at 800 yards. The American gunners fire in controlled bursts, 6 to 9 rounds, shift aim, 6 to 9 more. At this range, the 8mm Mauser machine guns Bauer's troops carry are marginal at best. The MG-42s can reach out to 800 yards, but their 8mm rounds lack the mass to reliably penetrate vehicle armour. The 50 BMG doesn't have that problem. Bauer watches his lead half-track take fire. The armour-piercing rounds, black-tipped death travelling at 2,900 feet per second, punch through the vehicle's 8mm side armour like aluminium foil. The half-track slews sideways, smoke pouring from the engine compartment. The crew bails out and goes to ground. His second vehicle tries to manoeuvre, presenting the frontal armour. Better, 12 mm are thick, sloped. But the American gunner simply adjusts, and at 800 yards, a dozen 50 caliber AP rounds turn the crew compartment into a kill zone. The half-track rolls to a stop, occupants no longer capable of evacuation. Bauer orders smoke and withdrawal. He's lost 4 vehicles and 30 men in 8 minutes, and his force hasn't closed to within effective range of the enemy. That night, he writes in his after-action report, American heavy machine gun, caliber approximately 12.7 millionths, displays range and penetration characteristics previously associated only with anti-tank rifles. Recommend armoured vehicles avoid engagement at ranges beyond 400 metres, unless supported by direct-fire artillery. The report circulates through Wehrmacht intelligence channels. Most commanders file it away, assuming Bauer encountered a fluke, an outlier, an exaggeration born of defeat. They'll learn differently. Lieutenant Robert Rosie Rosenthal rides in the ball turret of the B-17F Rosie's Riveters, part of the 100th Bomb Group's doomed mission to Regensburg. Around him, 146 flying fortresses drone through German airspace, in a formation so vast it takes 17 minutes to pass any given point. The Luftwaffe comes to meet them. FW-190s and Bf-109s attack in waves, head-on passes that close at a combined speed of 600 miles per hour. This is the killing ground, beyond fighter escort range, deep in German airspace, where American bombers must rely on their own defensive armament. Each B-17 bristles with 13 50 caliber positions, nose guns, cheek guns, top turret, ball turret, waist guns, tail guns, overlapping fields of fire designed to create a sphere of lead that no fighter can penetrate. Theory says this works. Practice is about to test theory. Rosenthal sees the first FW-190 at 2 o'clock high, rolling into its attack dive. The fighter's cannon spark 20mm shells that can kill a B-17 in a single burst. But to get close enough for accurate fire, the German pilot must fly through the bomber formation's defensive zone. 50 50 caliber machine guns open fire simultaneously. The noise is indescribable. Not individual shots, but a continuous roar, a wall of sound that drowns out the Wright Cyclone engines. The tracers, every 5th round, create visible streams of fire, glowing lines that reach out toward the attacking fighters like the fingers of some mechanical god. The FW-190 flies into this maelstrom and simply disintegrates. Rosenthal doesn't see a single catastrophic hit. He sees the fighter come apart in pieces. Cowling, wing panel, canopy fragments, and finally the cockpit section tumbling out of the formation, trailing smoke and fuel and pieces of pilot. The engagement lasts 45 minutes. The 100th Bomb Group loses 9 aircraft, catastrophic losses. But the Luftwaffe loses 36 fighters, and more importantly, experienced pilots that Germany can't replace. Hauptmann Hans Philipp, a Luftwaffe ace with 206 confirmed kills, tells his wingman after breaking off the attack, "It's like flying into a wall of steel. The Americans don't aim. They just fill the sky with bullets. Eventually, mathematics wins." Philipp will die 2 months later, shot down over Nordhorn. Whether it was 50 caliber fire that killed him, no one knows. But the odds say yes. German soldiers, when captured, often ask American interrogators about the 50 caliber gun. The conversations reveal a fundamental misunderstanding. They're trying to compare it to the MG-42, the Hitler's buzzsaw, that fires 1-200 rounds per minute and represents the pinnacle of German machine gun design. But the comparison is flawed. The MG42 and M2 aren't competitors. They're different answers to different questions. The MG42, firing 8mm Mauser at 1,200 RPM, is designed for area suppression. It fills zones with bullets, makes infantry keep their heads down, denies terrain through volume of fire. It's brilliant at this role, arguably the best infantry machine gun of the war. The M2, firing 50 BMG at 450-600 RPM, is designed for destruction. It doesn't suppress, it eliminates. Aircraft, vehicles, fortifications, and yes, personnel, all receive the same treatment. Where the MG42 says, "You can't cross this CA field," the M2 says, "This position no longer exists." Rate of fire versus destructive power, volume versus violence, different philosophies of war. An interrogation report from August 1944 captures a German Feldwebel's assessment. The MG42 is a superior infantry weapon. But the American .50 caliber, it is not an infantry weapon. It is artillery that happens to look like a machine gun. You cannot fight it with small arms any more than you can fight a tank with rifles. That's grudging respect from a professional soldier who understands exactly what he's facing. The M2's versatility extends beyond Europe. In the Pacific, Navy PT boats mount multiple .50s for close-quarters combat against Japanese barges and coastal positions. Lieutenant John F. Kennedy's PT-109 was famously equipped with them, though Kennedy's boat was lost before its gun saw significant action. But PT-59, under Lieutenant Commander Robert Lee, becomes a floating platform for Deuce. The boat carries 4 twin .50 mounts, 8 guns total, plus a 37mm cannon. When Lee's boat encounters a convoy of Japanese barges evacuating troops near Leyte, the engagement is brutally one-sided. The wooden barges have no armour. The .50 caliber rounds punch through both sides of the hull, through whatever's in between, cargo, equipment, human beings, and out the other side. Lee's gunners fire 12,000 rounds in a 20-minute engagement. 6 barges sink. The survivors beach themselves and surrender. A captured Japanese naval officer later tells interrogators, "We thought your machine guns were 20mm cannons. We could not believe these were small arms. The destruction was complete." By the time Germany surrenders in May 1945, the M2 Browning has proven itself in every theatre, every climate, every role. From the sands of North Africa to the hedgerows of Normandy, from 30,000 feet above Berlin to sea level in the Pacific, Deuce delivers. American production figures tell the story: 400,000 M2 machine guns manufactured during the war. Roughly 3 billion rounds of 50 BMG ammunition produced. 3 billion rounds. That's the American way of war. Not elegance or efficiency, but overwhelming material superiority delivered with mechanical reliability. And every German soldier who survived the war carried memories of that distinctive sound. Thump, thump, thump. The sound of American abundance. The sound they learned to fear. March 15th, 1944. 22,000 feet above Augsburg, Germany, Major Gerald Johnson rolls his P-47D Thunderbolt into a diving attack, and 8 .50 caliber machine guns roll with him. The target is a formation of Bf-110 heavy fighters climbing to intercept Allied bombers. The German pilots see Johnson coming. They have to. The P-47 is a 7-ton monster that doesn't believe in stealth. And they break formation, trying to scatter before the American reaches firing range. They don't scatter fast enough. Johnson presses the trigger on his control stick at 400 yards. All 8 M2. Brownings fire simultaneously, synchronized through hydraulic interrupter gear. The combined rate of fire is 4,800 rounds per minute, 80 bullets per second. and each bullet weighs half an ounce and carries the kinetic energy of a baseball bat swung by a professional slugger. The math is simple and horrifying. Johnson's aircraft is projecting 40 pounds of lead per second into a cone of airspace roughly 20 feet in diameter. The first Bf-110 flies into this cone and ceases to be an aircraft. The 50 caliber rounds shred the starboard engine cowling, punch through the wing root fuel tanks, saw through control cables, and turn the cockpit into a slaughterhouse. The fighter breaks apart in mid-air, wings folding upward like a closing book before the whole assembly tumbles out of the sky trailing smoke and fuel and pieces of airframe. Johnson's gun camera footage shows the engagement lasted 2.3 seconds. One trigger pull, one dead aircraft, 84 pounds of ammunition expended. This is the P-47 Thunderbolt at work, a fighter designed around the principle that you can never have too much gun. When Republic Aviation designed the P-47, they started with the question, how much firepower can we physically fit into a fighter aircraft? The answer turned out to be 850 caliber M2 Brownings, 4 in each wing, with 425 rounds per gun. Total ammunition capacity, 3,400 rounds. Total weight of fire per second when all guns are firing, 40 pounds. For comparison, the British Spitfire Mark IV carried 8 303 caliber machine guns that together projected 8 pounds per second. The German FW-190 carried 4 20mm cannons and 2 7.92mm machine guns. Impressive, destructive power, but only 180 rounds total for the cannons, meaning 3 seconds of sustained fire before the main armament was empty. The P-47 could fire continuously for 30 seconds before running dry. This wasn't an accident. American aviation doctrine took a fundamentally different approach to aerial gunnery than European powers. The Germans and British, operating under tight material constraints, favoured heavy cannons. Fewer rounds required to destroy a target, therefore less ammunition weight, therefore better aircraft performance. The Americans, unconstrained by material shortages, asked, why choose? Why mount cannons with 180 rounds when you could mount 50 caliber guns with 3,400 rounds? Yes, individual rounds were less destructive, but if you could put 8 times as many rounds into the air, who cared about individual destructive power? And the 50 BMG, despite being just a machine gun round, turned out to be devastatingly effective against aircraft. The AP and API, armour-piercing incendiary, variants could penetrate engine blocks, fuel tanks, and cockpit armour. The high velocity meant flat trajectory and predictable ballistics. And the sheer volume of fire compensated for the difficulty of aerial gunnery. Lieutenant Colonel Francis Gabby Gabreski, the top P-47 ace, in Europe with 28 confirmed kills, explained it simply. The Krauts had to hit you. We just had to get close. 850s hosing down a target area. Something's going to connect. Law of averages. If the P-47 was firepower concentration, the B-17 Flying Fortress was firepower distribution. Boeing's engineers faced a different problem. How do you defend a large, slow bomber operating hundreds of miles behind enemy lines? The answer was to turn the aircraft into a flying hedgehog, so heavily armed that attacking it became suicidal. The B-17G, the definitive late-war variant, carried 13 50 caliber positions, twin cheek guns in the nose, twin chin guns under the nose, twin waist guns on each side of the fuselage, twin tail guns, a top turret with twin guns, a ball turret underneath with twin guns, a single gun in the radio compartment. Each position covered specific arcs of fire. Together, they created overlapping fields that theoretically left no dead zones. Any fighter attempting an attack would face multiple 50 caliber streams simultaneously. Theory met practice over Germany, and practice was written in blood on both sides. Oberleutnant Heinz Knoke, a Luftwaffe ace who survived the war with 33 confirmed kills, described attacking B-17 formations in his memoir. You see the bombers ahead, perhaps 50 aircraft in formation. You think, how can I miss such large targets? Then you close to firing range and the entire formation lights up, muzzle flashes everywhere, traces creating a web of fire. You fly into this and either you are very lucky or you are very dead. There is no skill involved at this point, only luck. The numbers support Knoke's assessment. During the costly daylight bombing raids of 1943-44, the Luftwaffe lost fighters at rates they couldn't sustain. The Americans lost bombers, terrible losses, missions where 10 to 15% of aircraft failed to return. But the Luftwaffe lost experienced pilots, and Germany couldn't replace them. A single B-17 formation of 36 aircraft fielded 468 50 caliber machine guns. When German fighters attacked, hundreds of guns fired simultaneously. The traces alone were psychologically devastating. Visible streams of fire that let you watch death reaching out toward you. Hauptmann Hans-Joachim Marseille, before his death in 1942, called the American bomber boxes Fliegenden Festungen mit zu vielen Zähnen, flying fortresses with too many teeth. If the B-17 spread its 50 caliber guns across multiple positions, the Douglas A-26 Invader concentrated them in one devastating package. The attack bomber variant mounted 8 50 caliber M2s in the nose, all fixed forward, all firing simultaneously. For ground attack missions, this created an entirely new category of aircraft, the gun platform with bombs as a secondary armament. Captain Robert Mitchell, flying A-26 in the Pacific, described engaging a Japanese supply convoy. We came in low, maybe 200 feet, and opened up, all 850s firing. The traces looked like a solid beam of light. We hit a truck and it just vaporized. Didn't explode, didn't burn, just came apart under the impact. We didn't need the bombs. The guns alone were enough. The A-26 could carry 400 rounds per gun, giving it sustained firepower of 32 pounds per second for 15 seconds of continuous fire. Against soft targets, trucks, buildings, personnel, this was apocalyptic. Aircraft-mounted M2s pushed the weapon's development in ways ground versions never did. The need for synchronized fire through propeller arcs, the demands of high-altitude cold, and the desire for maximum rate of fire led to the AN-M2 variant. Changes included lighter bolt and operating components to increase cycle rate to 750 Fries 850 RPM simplified barrel change mechanisms, though aircraft guns rarely needed field changes, modified feed systems to handle the vibration and G-forces of aerial combat, electrical heating elements for high-altitude operations. These modifications migrated back to ground versions over time, improving the entire M2 family. The question haunted US military planning. Should we switch to 20mm cannons like everyone else? The British had the Hispano 20mm, the Germans had the MG 151-20 and MG FF. The Japanese had the Type 99. All were effective, all were proven, and all offered more destructive power per hit than 50 caliber. But every analysis reached the same conclusion: stick with the 50. The reasons were practical. Ammunition capacity, 300-400 rounds of 50 cal versus 180 rounds of 20 mm in the same weight. Reliability. The M2s worked. Cannon systems were finicky, prone to jamming logistics. America was already producing billions of 50 Posses BMG rounds. Training. Gunners were already qualified on the M2 versatility. The same gun served ground, naval, and air forces. Most importantly, the 50 cal was good enough. Not optimal for every situation, but adequate for all of them. And in a global war fought across every theatre simultaneously, adequate for everything beat optimal for something every time. By war's end, American aircraft had fired an estimated 1.8 billion rounds of 50 BMG ammunition in air-to-air and air-to-ground combat. The 8 guns of the P-47, the 13 positions of the B-17. the concentrated nose armament of the A-26, all prove that John Browning's 1918 design scaled to roles he never imagined. And German pilots who survived the war carried one consistent memory: the sight of muzzle flashes lighting up a bomber formation, the traces reaching out like fingers, and the sudden, terrible understanding that you were flying into a wall of steel. Some walls you can't fly through. Fort Knox, Kentucky, July 1943. The brass cartridge sitting on Colonel William Crisp's desk looks deceptively simple. A 4-inch cylinder of copper-washed steel topped with a pointed projectile. It weighs less than 4 ounces. It costs the Army roughly 48 cents to manufacture, and it's about to redefine what pointies caliber means. Chris picks up the round carefully, examining the tip. Instead of the standard copper jacket, this projectile wears a black coating. Underneath the jacket, a hardened steel core waits to meet German armour plate. M2 armour piercing, the Ordnance technician explains, penetrates 3/4 of an inch of rolled homogeneous armour at 500 yards. Vehicle hulls, aircraft engine blocks, concrete fortifications, it'll punch through. Chris sets down the black-tipped round and picks up the next one. This tip is silver-coloured, painted with a distinctive marking. M1 incendiary, magnesium compound in the nose cavity, ignites on impact. Fuel tanks, ammunition stores, wooden structures, anything flammable. The third round combines both features, a silver tip with red sealant. M8 armour-piercing incendiary, does both jobs, penetrates, then ignites whatever's on the other side. Chris understands immediately. This isn't just ammunition variety, it's tactical flexibility loaded into a belt. A gunner can engage armour with AP, switch to incendiary for fuel trucks, alternate between them for maximum effect. One weapon, infinite applications, determined by what you feed it. How fast can we produce these? Chris asks. As fast as you can use them, sir? The 50 BMG cartridge family evolved faster than the M2 itself, a constantly expanding toolkit that made the gun more lethal with each variant. M2 ball, the baseline, a 709-grain full metal jacket bullet travelling at 2,900 to 10 feet per second, generating 13,104 foot-pounds of muzzle energy. Effective against personnel, light vehicles and structures. Not specialised, but devastatingly effective through sheer kinetic force. M2 armour piercing, black tip, a hardened steel core wrapped in copper jacket. The core concentrates force on a smaller impact area, allowing penetration of armour that would stop ball ammunition. At 500 yards, it punches through 0.75 inches of steel plate. At 200 yards, over an inch. German half-tracks, Japanese bunkers, Italian tankettes, all vulnerable. M1 incendiary, silver tip. A magnesium igniter in the projectile nose, triggered by impact. The round doesn't just hit, it ignites. Fuel storage, ammunition dumps, aircraft on the ground, wooden fortifications. The round creates fire where fire causes maximum damage. M8 API, silver with red seal. The hybrid. Armour-piercing core with incendiary payload. It penetrates armour, then ignites fuel, ammunition, or hydraulic fluid on the other side. This became the standard loading for anti-aircraft and anti-vehicle work. Why choose between penetration and fire when you can have both? M20 APIT, red tip, armour-piercing incendiary tracer. The API ran with a tracer element in the base that burns for 1,500 yards. The gunner can watch his rounds reach out, adjust fire in real time, and walk tracers into the target. Every fifth round in a standard belt was APT, creating those distinctive rope of light streams that terrified enemy forces. By 1945, a standard loading for anti-vehicle work was 4 M8 API, 1 M20 APIT, repeat. Continuous armour-piercing incendiary fire with built-in trajectory reference. While ammunition engineers multiplied the M2's lethality, vehicle designers multiplied the guns themselves. The M45 Maxim quad mount, officially the multiple caliber 50 machine gun carriage, M45, mounted 4 M2 Brownings on a single powered turret. The system appeared on M16 half-tracks, creating mobile anti-aircraft platforms that could also devastate ground targets. Technical specifications don't capture the visceral impact. 4 50 caliber machine guns, synchronized fire, combined rate of 2,400 rounds per minute, all controlled by a single gunner seated behind a computing site. Staff Sergeant Thomas McPherson, 14th Armoured Division, operated an M16 during the drive across Germany in early 1945. We called it the Meat Chopper. Official name was something else, but every crew called it the Meat Chopper. 450s firing together. It didn't sound like a weapon. It sounded like the world ending. The Maxim mount's electric traverse and elevation motors allowed the gunner to track aircraft with precision impossible for manual mounts. But the system proved equally devastating against ground targets. German infantry caught by quad 50 yards fire simply ceased to exist as organised units. An after-action report from March 1945 describes an M16 engaging German infantry in a tree line. Engagement duration approximately 20 seconds, estimated 800 rounds expended, enemy casualties estimated 40 to 60. Enemy resistance ceased immediately. 1 vehicle, 20 seconds. An infantry platoon eliminated. The M2 Browning emerged from W2 essentially unchanged, proof of design excellence. But ammunition development accelerated, transforming an already lethal weapon into something approaching science fiction. Chrome-lined barrels, 1950s. The barrel, not the action, was the M2's limiting factor for sustained fire. Chrome plating the bore increased barrel life by 300%, reduced cleaning requirements, and maintained accuracy through extended firing sessions. A chrome-lined barrel could fire 10,000 rounds before accuracy degraded. Earlier versions needed replacement at 3,000. Raufoss Mk211, multi-purpose, 1980s. Developed by Norwegian company Nammo, this round combined 3 effects in one projectile: armour-piercing, explosive, and incendiary. A tungsten penetrator punches through armour, followed by a high-explosive charge that detonates inside the target, followed by incendiary zirconium powder that ignites everything. Against armoured vehicles, Raufoss penetrates, explodes internally, and sets fire to fuel and ammunition. Against aircraft, it destroys structural components, detonates in fuel tanks, and ignites hydraulic systems. Against personnel in cover, the effect is apocalyptic. 1 round, 3 effects, maximum lethality. SLAP, Saboted Light Armour Penetrator, 1990s, for heavily armoured targets. The SLAP round uses a sub-caliber tungsten penetrator held in a plastic sabot. At impact, the sabot falls away and the dense penetrator continues, travelling faster and hitting harder than a full-caliber projectile. SLAP penetrates over an inch of armour at 500 yards, making the M2 lethal against infantry fighting vehicles and light armoured personnel carriers. The gun John Browning designed in 1918 can now defeat armour that wouldn't exist for 70 years. A contemporary M2 gunner's belt might contain M33 ball, standard for general purpose, M8 API, armour incendiary, Mk211, Raufoss, multi-purpose devastation, M962, SLAP T, heavy armour penetration with tracer, mixed loadings allow engagement of any target with appropriate ammunition. See an unarmoured truck, ball rounds work fine. See a BMP infantry fighting vehicle, switch to SLAP. See fuel storage, API or Raufoss. 1 gun, 1 belt, infinite tactical applications. Here's the fascinating reality. The M2 Browning hasn't changed fundamentally in a century. The bolt design, the short recoil system, the feed mechanism, all essentially identical to the 1933 version. But the ammunition has evolved through 6 generations, each multiplying the weapon's lethality. The gun is the same. What it fires has become exponentially more lethal. This is the opposite of normal weapons development, where platforms constantly upgrade while ammunition remains static. The M2 proved so reliable, so adaptable, that engineers focused on ammunition instead, knowing that whatever new round they developed, Deuce would fire it reliably. And fire it she did. From incendiary rounds setting Japanese fuel dumps ablaze in Deuce, to Raufoss rounds defeating Soviet BMPs in Afghanistan, to slap penetrators punching through ISIS technical armour in Iraq. The ammunition evolved, but the gun remained. Colonel Christ, examining those first AP and incendiary rounds in 1943, couldn't have imagined Raufoss or slap. But he understood the principle: give a reliable weapon better ammunition, and you multiply combat effectiveness without retooling production, retraining gunners, or redesigning tactics. It's the most American approach possible. If it works, don't replace it. Just make it more lethal. November 28, 1950, Chosin Reservoir, North Korea. 35 degrees. Corporal Raymond Davis's hands have gone numb. Not the pins and needles numbness of poor circulation, but the deep, bone-cold numbness that precedes frostbite. He can barely feel the M2's charging handle as he racks it for the third time in 10 minutes. The gun fires twice and stops, frozen. Around him, the Chinese 9th Army Group is launching human wave attacks against the surrounded 1st Marine Division. In the darkness, bugles sound, a noise that will haunt Marine veterans for decades. Thousands of Chinese infantry surge forward through the Korean mountain passes, betting that American firepower will fail in the Arctic cold. Most American weapons are failing. M1. Garen's jam as lubricating oil congeals in the cold. Bars freeze after a few rounds. Mortars crack from thermal stress. The carefully maintained arsenal of W2 vintage weapons meets an environment they were never designed for. But not Deuce. Davis pours a canteen of precious hot coffee over the M2's action, a trick the old sergeants taught him. Steam rises from the metal. He racks the charging handle again, feels the bolt move freely, and opens fire. The gun runs. For the next 6 hours, as the temperature drops to 40 degrees, as Chinese infantry attack in waves that seem infinite, Davis's M2 fires continuously. He changes barrels 3 times, the frozen metal burning through his gloves. He feeds belt after belt through the action. And the gun, designed 20 years earlier in Utah's temperate climate, performs flawlessly in conditions that would kill an unprotected human in minutes. When dawn breaks and the Chinese withdraw, Davis's position is an island of brass casings in a sea of snow turned red. His M2, barrel still glowing despite the Arctic air, has fired an estimated 11,000 rounds through the night. The weapon that defeated Germans in France just saved Marines in Korea. Korea proved the M2's environmental versatility. If W. tested the gun across theatres, Korea compressed those tests into a single peninsula. Arctic winters, tropical summers, mountainous terrain, and an enemy doctrine built on overwhelming infantry mass. The M2 answered every challenge. Mounted on M4 Sherman tanks, WWIMA veterans themselves, the 50 cal became the primary weapon for breaking up Chinese infantry attacks. Tank commanders learned to fire low, letting 50 caliber rounds skip across frozen ground into advancing formations, a technique impossible with main guns but devastatingly effective with machine guns. On Navy destroyers providing fire support, M2s engaged coastal targets and North Korean supply vessels. In the air, F-4U Corsairs and F-51 Mustangs, both carrying multiple .50s, provided close air support that Marines called divine intervention with tracer rounds. But Korea added something new to the M2's resume, the realization that this WW-era weapon would serve for decades, not years. As the war ground toward armistice in 1953, military planners understood they weren't replacing Deuce anytime soon. Why would they? It worked in France and it worked in frozen Korea. Chances were good it would work wherever America fought next. March 1967. Route 19, Central Highlands, Vietnam. Specialist 4, Michael Fitzsimmons, stands behind a pedestal-mounted M2 in the bed of a modified M35 Deuce and a half cargo truck. Armour plate surrounds him, scrounged metal, sandbags, and welded steel that makes the truck look like a Mad Max fever dream. They call it a gun truck, and Fitzsimmons' vehicle, nicknamed Eve of Destruction, carries 3 M2 Brownings and 1 M60. It's part of a convoy running supplies from Quy Nhon to Pleiku, through territory the Viet Cong control after dark and contest during daylight. The ambush comes at the expected place, a curve in the road where jungle presses close on both sides. AK-47 fire erupts from the tree line, followed by RPG trails. Fitzsimmons doesn't aim carefully. He doesn't have time. He simply pivots the M2 toward the muzzle flashes and holds down the trigger, walking fire across the jungle canopy at 550 rounds per minute. The 50 caliber rounds don't just penetrate jungle foliage, they obliterate it. Trees 6 inches in diameter snap under repeated impacts. Branches rain down. And somewhere in that vegetation, human beings who thought jungle provided concealment learn the same lesson German infantry learned in Normandy. Concealment is not cover. The ambush breaks in under a minute. The convoy keeps rolling. This is Vietnam's contribution to M2 tactics. The gun truck, an improvised platform that turned logistics convoys into armoured columns. Unable to secure every mile of highway, unable to spare infantry escorts for every supply run, American forces instead fortified the trucks themselves, and the M2 became the primary armament. By 1970, gun trucks were official doctrine, with standardized armor packages and weapons mounts. The M2 remained the weapon of choice, heavy enough to defeat cover, reliable enough to function in Vietnam's heat and humidity, with range to engage ambushes before they closed to effective AK-47 range. While the Army rolled gun trucks down highways, the Navy sailed them down rivers. The Brown Water Navy, riverine patrol forces operating on the Mekong Delta's countless waterways, mounted M2s on everything that floated. PBR, Patrol Boat River, craft carried twin 50s in forward turrets. Monitor riverboats, converted landing craft, bristled with multiple M2 positions, plus 40mm cannons and mortars. Engineman Second Class Terry Lynch, operating a PBR on the Bassac River, described the M2's advantage. The jungle comes right to the water's edge. Charlie's 10 feet away, hidden in vegetation so thick you can't see 3 feet in. You can't outrun him, can't see him to shoot rifles. But the 50 just mows down everything. Trees, brush, spider holes, whatever. You make your own clear zone. The M2's penetration meant riverine gunners didn't need to see targets. They could fire through vegetation, through mud banks, through the wooden sampans Viet Cong used for transport. The weapons range meant patrol boats could engage shore positions before enemy rockets and recoilless rifles reached effective range. Vietnam's riverine operations proved the M2's versatility in yet another environment. Tropical waterways, high humidity, fine sediment, constant exposure to water. The gun performed. By the 1980s, the M2 had served for 50 years without fundamental changes. But operational experience, from Korea's cold to Vietnam's heat to countless training exercises, identified improvements. The result was the M2A1, introduced in 2010. The changes were minimal by design. Quick change barrel, QCB. Previous M2s required headspace and timing adjustments whenever barrels were changed, a process requiring gauges, training and time. The M2A1's fixed headspace design eliminated this. Puller handle, remove hot barrel, insert cool barrel, close handle. 10 seconds. No tools, No adjustment. A single gunner could now change barrels under fire without assistance. Flash suppressor. Reduces visible signature during night firing. The M2's muzzle flash could reveal positions. The suppressor minimises this without affecting ballistics. Manual safety. The original M2 had a trigger-based safety that could accidentally discharge if the bolt was released with the trigger depressed. The M2A1 added a mechanical safety lever, simple, positive, impossible to accidentally disengage. Improved ejection system, brass deflector prevents spent cases from hitting nearby personnel or equipment, important for vehicle-mounted operations. These weren't revolutionary changes. They were refinements based on a century of operational feedback. The M2A1 is still fundamentally John Browning's design. It's just been debugged by 5 generations of gunners. The newest evolution isn't the gun. It's where you put it. Remote weapon stations, RWS, like the Common Remotely Operated Weapon Station, CROWS, mount an M2 on a vehicle roof with a camera, laser rangefinder, and electric traverse and elevation motors. The gunner sits inside the armoured hull, watching a screen, aiming with a joystick, firing with a button. Same M2, same ammunition. But now the gunner isn't exposed to enemy fire, isn't vulnerable to the environment, and can engage targets from the protection of the vehicle interior. In Iraq and Afghanistan, RWS-mounted M2s became standard on mine-resistant ambush-protected MRAP vehicles. The gunner who would have been standing in a turret hatch, exposed to snipers, RPGs and IEDs, instead operates from inside, while Deuce does the same job it's done for a century. Sergeant First Class Marcus Williams, operating an MRAP-mounted CROWS in Helmand Province, 2011. Same gun my grandfather used in Korea, same gun my dad used in Desert Storm. Now I'm using it from inside the vehicle with thermal sights and a laser rangefinder. The gun hasn't changed. Everything around it has. From Chosin's frozen hell to Vietnam's jungle rivers to Iraq's urban ambushes, the M2 Browning remained constant. Tactics evolved, platforms changed, technology advanced, but Deuce stayed the same. Because it worked in 1933, and it worked in 1950, and it worked in 1967, and it worked in 2011. Some designs transcend their era. They become permanent fixtures, reference points around which everything else evolves. The M2 Browning is one of these rarities, a weapon so fundamentally sound that generations of engineers looked at it and concluded we can improve the ammunition, we can improve the mount, we can improve the sights. But the gun itself? The gun is fine. Staff Sergeant David Balavia's MRAP rocks from an RPG impact as his convoy pushes into the city's industrial district. Through the armoured glass, he sees muzzle flashes from a 3-storey building 400 metres ahead. Insurgents with PKM machine guns engaging the column. Balavia doesn't grab a radio to call for air support. He doesn't request artillery. He doesn't even dismount his infantry. He just pivots the CROWS joystick, centres the thermal reticle on the building's 2nd floor, and presses the trigger. The M2 mounted above his vehicle fires 27 rounds in a controlled burst. Through the screen, Belavia watches the 50 caliber impacts walk across the concrete facade, punch through the wall, and eliminate the firing position. The PKM falls silent. Elapsed time from first contact to target neutralized, 11 seconds. Belavia keys his radio. Threat eliminated, moving. This is the M2 Browning in the 21st century. Same gun, same mission, same result. The weapon John Moses Browning designed when Herbert Hoover was Secretary of Commerce is still killing America's enemies in an era of smartphones, drones, and precision-guided munitions. And nobody serious is trying to replace it. The Pentagon has tried. God knows they've tried. Every decade or so, some acquisition program proposes replacing the M2 with something modern, something networked, something that reflects current technology. The proposals come with PowerPoint presentations, cost-benefit analyses, and promises of revolutionary improvements. And every time, the programs die. The XM806 lightweight 50 caliber machine gun 2000s promised 40% weight reduction through advanced materials, would have made the M2 more portable, easier to deploy. The program spent $15 million before cancellation. Why? The weight savings weren't worth the cost of replacing 50,000 existing M2s that worked perfectly fine. The XM312 2000s, designed as a modular system that could fire 50 silos of BMG or 25mm airburst rounds, theoretically superior to the M2 in every way. The problem? It fired only 260 rounds per minute compared to the M2's 500 plus. In testing, soldiers consistently preferred the old gun. Program cancelled. The M2A2, proposed, would have added QCB system plus improved optics rails. But the M2A1 update already added QCB, and optics rails could be retrofit to existing guns. No need for a complete replacement. The pattern is consistent. Proposed replacements either cost too much for marginal improvements, or they actually perform worse than the system they're meant to replace. And beneath all the technical justifications lies a simple truth. Why spend billions replacing a weapon that still does its job perfectly? Sergeant First Class Raymond Cooper, Armour Section Leader, 1st Cavalry Division, runs a training range at Fort Hood. He's been teaching soldiers to operate the M2 for 16 years. His father taught M2 operation during Desert Storm. His grandfather crewed an M2 armed half-track in Germany, 1945. 3 generations. 1 weapon system. The knowledge base is insane, Cooper explains. Every NCO knows this gun inside and out. Every armourer can fix it blindfolded. Every logistics chain stocks parts. You can pull an M2 from a museum, and any E5 with a cleaning kit can make it run. Try that with a new system. This institutional knowledge is worth billions in hidden value. Training materials exist for every possible scenario. Troubleshooting procedures have been refined through a century of use. Parts commonality means one spare parts inventory supports ground vehicles, aircraft, watercraft, and static positions. A new weapon means new training pipelines, new maintenance procedures, new logistics chains, new troubleshooting manuals, new institutional knowledge built from scratch. The M2 comes with a century of accumulated wisdom already paid for. Afghanistan's mountain warfare provided the ultimate test of the M2's modern relevance. In the thin air of Helmand Province's high valleys, the 50 caliber's long range proved decisive. Combat Outpost Keating, October 2009. Outnumbered American forces used M2s to engage Taliban positions at ranges exceeding 1,000 metres, beyond effective range of M4 rifles, M240 machine guns, or Taliban small arms. The 50's ability to reach out and destroy distant positions made the difference between defence and annihilation. Captain Justin Sachs, who commanded during the battle, "The 50's gave us reach the Taliban couldn't match. They'd set up mortars at 1-200 metres, thinking they were safe. We'd hit them with the 50's and watch them scatter." That weapon saved lives by keeping the enemy beyond effective range. Urban combat in Iraq presented different challenges. Close quarters, civilians, buildings. The M2 adapted. Precision fire through walls to eliminate specific rooms. Controlled bursts to disable vehicle-borne IEDs at checkpoints. Suppressive fire that convinced insurgents that fighting from that position was suicidal. Same gun, different tactics, consistent results. Here's what nobody talks about. The M2 is absurdly cost-effective. An M2A1 costs approximately $14,000 to manufacture. Expensive compared to infantry rifles, cheap compared to any modern weapon system. Compare this to Javelin anti-tank missile, $175,000 per round. Hellfire missile, $115,000 per round 30mm cannon system for vehicles, $300,000 plus per installation. The M2 fires rounds costing $5 each, depending on ammunition type, can engage everything from personnel to light vehicles to aircraft, requires minimal maintenance, and lasts for decades. From a pure cost-per-effect analysis, few weapons systems offer better value. You can destroy a $50,000 technical vehicle with $15 worth of 50 TARS caliber ammunition. And in a military budget measured in hundreds of billions, the ability to solve problems cheaply becomes strategically valuable. The M2's longevity isn't just American stubbornness. 43. Allied nations use the M2 or license-built variants. NATO standardization means British, Canadian, Australian and European forces all train on the same weapon system. This interoperability proved crucial in Afghanistan and Iraq, where coalition forces shared ammunition, spare parts, and even weapons themselves. A Canadian LAV-25's M2 could use American ammunition. An Australian Bushmaster's 50 could mount on a US gun ring. One weapon, one ammunition, one training standard, 43 militaries. Try coordinating that with 43 different modern weapon systems. In 2033, the M2 Browning will celebrate its centennial. Current projections suggest it will remain in frontline service. Think about that. A weapon designed when commercial radio was cutting-edge technology will still be killing enemies in an era of autonomous drones and directed energy weapons. This isn't nostalgia. It's not resistance to change. It's the recognition that some designs achieve a kind of permanence. They solve their intended problem so well that changing them isn't improvement, just difference. The M2 Browning fires a half-inch projectile at 2,900 feet per second with mechanical reliability. It did this in 1933. It does it today. It will do it in 2033 because physics doesn't change, metallurgy doesn't obsolete, and a properly designed machine, maintained and operated correctly, doesn't age. It just accumulates history. Deuce has accumulated a century of history, and she's not done yet. April the 30th, 1945. Torgau, Germany. The Elbe River. Klaus Weber walks toward the American checkpoint with his hands raised, his Soldbuch identification papers held in trembling fingers. Behind him, what remains of the Wehrmacht is disintegrating, units dissolving, soldiers discarding uniforms, officers burning documents. The war is ending. Everyone knows it. An American MP, impossibly young and impossibly well-fed compared to the gaunt German survivors, takes Klaus's papers and waves him toward a holding area. Klaus walks past American vehicles, Shermans, half-tracks, trucks, jeeps, all in perfect condition, all with full fuel tanks, all crewed by soldiers who look like they've never missed a meal, and mounted on nearly every vehicle, the gun. That gun, the 50 caliber. Deuce, 9 months since Klaus first heard that sound in the hedgerows south of Mortagne. 9 months of retreat across France, through Belgium, into Germany itself. 9 months of that distinctive thump, thump, thump following him like a mechanical heartbeat, always getting closer, never stopping. In the holding area, Klaus finds Manfred Kolk, the baker's son from Hamburg, who survived the same hedgerow. They don't embrace. They just nod. Two men who share a specific type of knowledge. We lost, Manfred says. Statement of fact, no emotion. We lost the moment they brought those guns, Klaus replies, nodding toward an M3 half-track, its 50 caliber mount gleaming in the spring sunlight. They're not. Wrong. The numbers, compiled by US Army Historical Division in the years following the war, tell a story of industrial might translated into tactical dominance. Production. M2 Browning machine guns manufactured during the Eidpusu. 400,000 Osterud 50 BMG ammunition produced 1941-1945. 3.2 billion rounds average M2 lifespan before major maintenance. 10,000 rounds. Practical lifespan with barrel changes and maintenance. 100,000 plus rounds. Combat effectiveness, aircraft destroyed by 50 caliber fire, all theatres. Estimated 12,000–15,000 vehicles destroyed or disabled. Estimated 35,000 plus. German tactical doctrine modifications specifically citing .50 cal threat. 14 documented revisions. Recommended minimum engagement distance. German field manuals, 1944, 1,200 metres, comparison statistics, 50 BMG muzzle energy, 13th item Mask FTLBs, 8mm Mauser muzzle energy, 2649 FTLBs ratio, 4.96.1. The M2 didn't just outperform comparable weapons, it occupied a different category entirely. The Germans had nothing equivalent. The MG42 was a superior infantry machine gun for its role. The 2cm Flak 38 was a capable anti-aircraft cannon, but neither matched the M2's combination of range, penetration, portability and reliability. The Americans had created a weapon that sat between small arms and cannons and discovered that this middle ground was devastatingly effective. Every army that faced the M2 gave it a name in their own language, and those names reveal how they perceived it. German, Grosser Kaliber Maschinengewehr. Large caliber machine gun, but more commonly .5, 10.50, or simply Das 50, the 50. In Normandy, some units called it der Hammerschlag, the hammer strike. Japanese Goju Kokeiju, 6.50 caliber gun, but soldiers reportedly called it Raijin no Ken, Thunder God's Fist. North Korean Chinese during Korea, Laogan Mu, Old Godmother, or Meguo Zhongqiang, American heavy machine gun. Viet Cong, Sung Nam Muoi. Gun 50, though some documents reference it as Voa Mai, American elephant, but the Americans characteristically gave it an affectionate nickname, Ma Deuce, a play on M2 that anthropomorphized the weapon. Not a tool, not a machine. Ma Deuce, like a person, like family. That affection was earned. The weapon brought soldiers home. It kept aircraft in the sky. It turned bad situations into survivable ones. The Germans called it the 50 with fear. The Americans called it Ma Deuce with love. Both names were appropriate. In the end, the M2 Browning represents something larger than one weapon system. It embodies the American approach to warfare that emerged in World War II and has continued through every conflict since. Material abundance over material efficiency. Why conserve ammunition when you can produce billions of rounds? Why use precision when you can use volume? The M2 fired 3.2 billion rounds in WDWC, an amount that would have bankrupted most nations. America just increased production. Reliability over optimization. The M2 isn't the lightest possible .50 caliber gun. It isn't the fastest firing. It isn't the most accurate, but it's reliable enough, light enough, fast enough, and accurate enough for every mission. And reliability beats optimization when you're fighting on 6 continents simultaneously. Institutional longevity over cutting-edge technology. America could have developed new machine gun systems every decade. Instead, they perfected one design and supported it for a century. The accumulated knowledge, spare parts infrastructure and training base become strategic advantages in themselves. Firepower concentration over maneuver elegance. European military traditions emphasize maneuver, elan, tactical sophistication. The American tradition emphasized bring more gun than the enemy, use it liberally, win through material superiority. Not elegant, devastatingly effective. Klaus Weber, sitting in that holding area in April 1945, understood this instinctively. The Americans hadn't beaten Germany through superior tactics or warrior spirit. They'd beaten Germany by producing so many tanks, planes, trucks and guns that German skill became irrelevant. And the 50 caliber machine gun was the perfect symbol of that abundance. A weapon so powerful it should have been rare, produced in such quantities, it became ubiquitous. Klaus Weber survived the war. He returned to his home in Bavaria to find it occupied by American forces. He worked as a translator for US Army administration, helped rebuild his town, married in 1947, raised 3 children. He died in 1989, 3 weeks after the Berlin Wall fell, having lived to see Germany reunified and prosperous. In his final years, his grandson asked him about the war. Klaus spoke reluctantly. Most veterans did. But when asked what he remembered most clearly, he didn't talk about the Eastern Front's brutality or the destruction of German cities. He talked about the sound. "That American machine gun," he said, "the heavy one, I can still hear it. That sound meant you were going to die, unless you were very fast and very lucky. We had good weapons. We had good soldiers. But that gun, it was like they brought a piece of the future to the battlefield, and the future always wins." Today, the M2 Browning serves with US forces in dozens of countries. It sits atop MRAPs in Africa, guards bases in the Middle East, equips Navy vessels worldwide, and trains new gunners at bases across America. The soldiers operating these weapons are 4 generations removed from the men who first fired them in anger. The enemies have changed, from Wehrmacht to North Koreans to Viet Cong to Iraqi insurgents to Taliban fighters. The platforms have evolved, from half-tracks to jet fighters to remote weapon stations. But Deuce remains, because some designs transcend their era. Some tools become permanent. Some machines become legends. The M2 Browning is all 3. It's the gun that made German veterans fall silent when they heard its distinctive report, that made Luftwaffe pilots break off attacks, that made enemy forces rout around its positions rather than confront it directly. It's the weapon that proved American industrial might could be translated into tactical dominance, that showed reliability and abundance could defeat sophistication and skill. It's Deuce, the 100-year gun, the soldier's friend, the enemy's nightmare. And when future historians write about American military power in the 20th and 21st centuries, they'll note the aircraft carriers and stealth fighters and precision missiles. But they should also note the machine gun that served from 1933 to whenever it's finally retired, probably decades hence. Because the M2 Browning didn't just help win wars, it defined what American firepower means: overwhelming, reliable, and absolutely unstoppable. The Germans were right to fear it. Everyone else learned to fear it too.